Ever looked up at the night sky and wondered about its deepest, darkest secrets? Today, we're diving headfirst into one of the universe's most mind-bending mysteries: black holes. What are they? What happens if you fall into one? And what secrets do they hide? Stick around, because we're about to take a journey to the edge of reality itself. So, what exactly is a black hole? Imagine a star, much, much bigger than our sun, running out of fuel. When it dies, it collapses under its own immense gravity. It squeezes all its mass into an impossibly tiny point. This point is called a singularity. The gravity here is so powerful that nothing, not even light, can escape its pull. That's why they're called black holes. They are the ultimate cosmic prisons. The boundary around a black hole, the point of no return, is called the event horizon. Cross that line and there's no coming back. To really understand black holes, we need to talk about space-time. Think of the universe as a giant, stretchy sheet of fabric. Massive objects like stars and planets create dips in this fabric. The bigger the object, the deeper the dip. This dip is what we feel as gravity. Now, a black hole isn't just a dip. It's an infinitely deep, bottomless pit in the fabric of space-time. It warps space so extremely that it creates a one-way trip to its center. This extreme warping of space-time has some truly bizarre effects, especially on time. This is where we get into something called gravitational time dilation. The stronger the gravity, the slower time passes. This isn't just a theory. It's been proven. The GPS satellites orbiting Earth have to constantly adjust their clocks because time moves slightly faster for them up there than it does for us down here on the surface. Now let's crank that up to a black hole's level. If you were in a spaceship safely orbiting a black hole, and you watched a friend fall toward it, you'd see something strange. As your friend got closer to the event horizon, they would appear to slow down. Their movements would get slower and slower until, right at the edge, they would seem to freeze in time, stuck there forever. But for your friend, the experience would be completely different. They wouldn't feel themselves slowing down at all. From their perspective, time would be ticking along normally. Instead, they would look back and see the entire future of the universe flashing before their eyes. Years, centuries, millennia would pass in the outside world in the blink of an eye for them. It is a chilling thought. You could watch the end of the universe while falling into a black hole. So, what happens as you actually cross the event horizon? Well, it depends on the size of the black hole. If it's a smaller, stellar mass black hole, the tidal forces would be immense. The gravity at your feet would be so much stronger than the gravity at your head that you would be stretched apart, like spaghetti. This gruesome process is actually called spaghettification. It's not a pleasant way to go. But if you fall into a supermassive black hole, the kind found at the center of galaxies, the story is different. These behemoths are so huge that the event horizon is much further out from the singularity. The tidal forces at the edge are gentle enough that you could cross the event horizon without even noticing. You wouldn't be spaghettified, at least not right away. You would just float peacefully past the point of no return. Once you're inside, there's no escape. All paths, every possible direction, lead to one place, the singularity at the center. The fabric of space-time is so warped that forward in time and toward the singularity become the same thing. No matter how powerful your rockets are, you can't turn back. You're on a one-way ride to the heart of the abyss. As you get closer to the singularity, the tidal forces would eventually become overwhelming, and spaghettification would be your inevitable fate. But this brings us to the biggest question of all. What is the singularity? What lies at the very center of a black hole? The honest answer is we don't know. Our current laws of physics, both Einstein's general relativity and quantum mechanics, break down at this point. They can't describe the conditions inside a singularity. Some theories suggest the singularity is an infinitely dense, infinitely small point where all the mass of the black hole is crushed. But infinity is usually a sign that our math is incomplete. Other, more speculative ideas propose that black holes could be portals to other universes. Perhaps the matter that falls into a black hole is spewed out through a white hole somewhere else, creating a new universe. This is the concept of a wormhole, a theoretical tunnel through space-time. While it's a fascinating idea popularized in science fiction, there's currently no evidence that wormholes exist. Another mind-bending theory is the holographic principle. It suggests that everything that falls into a black hole, all its information, isn't destroyed but is instead encoded on the two-dimensional surface of the event horizon, like a hologram. This would mean that our three-dimensional reality could be a projection of information stored on a distant 2D surface. It's a wild idea that challenges our very perception of reality. And then there's Stephen Hawking's groundbreaking discovery, Hawking radiation. He proposed that black holes aren't completely black. Due to quantum effects near the event horizon, black holes slowly leak radiation and particles back into space. This means that over an incredibly long time, longer than the current age of the universe, a black hole will eventually evaporate and disappear completely. But this raises a paradox. What happens to the information that fell in? Does it disappear forever? This is one of the biggest unsolved problems in physics today. From space-time warps and time travel to spaghettification and gateways to other universes, black holes push the limits of our understanding and imagination. They are the ultimate laboratories for testing the laws of physics, holding the keys to unlocking the deepest secrets of gravity, space, and time. While we've learned so much, the greatest mysteries remain. What is a singularity? What happens to the information they swallow? Answering these questions might require a whole new revolution in physics. The universe is full of wonders, and black holes are perhaps the most awe-inspiring of them all. They remind us how much we still have to learn. What do you think is inside a black hole? A portal to another dimension? The beginning of a new universe? Or just pure crushed oblivion? Let me know your craziest theories in the comments below. Thank you so much for joining me on this cosmic journey. If you enjoyed this deep dive into the unknown, please hit that like button and subscribe for more adventures into the mysteries of our universe. Until next time, keep looking up.